Now for the final problem, we're looking at this box here, right, going down at a certain rate, right? And we can see here that we're looking at, for this equation, ax1 is equal to g sine theta, right? Because we're not really concerned with the weight at this moment. We just know it's moving, right? And we will also be able to use this equation, which is f2x1 minus velocity initial x1 squared x, which is going to be equal to, I'm putting the bottom here since my screen is small, 2ax1 to delta x1, right? And if we were to rework that to find the velocity, right, because we were trying to like isolate velocity in the first question, right, to really understand what's going on, we could isolate it to v squared equals to 2g sine theta, right, to delta x1. And then from there, we could plug in the numbers, right, and we'll get v squared is equal to 2 times 10 times 1/2 times 3, where velocity is going to equal to the square root of 30, right? So that's the first part. Although we're not done, that is the first part, and it gives us some information on what to do next, right? So afterwards, after this part here, we would use now, right, because we have to pay attention here. It's the sum of forces of F, the sum of forces of fx1 is equal to max1, I guess max1, right? And we'll essentially use the same equation we've been using before, which is positive mg sine theta, because it's on the slope, right? Like we're looking at it here, minus fg equals, I'm putting it on the bottom again, I'm sorry, I'm putting R here, 1, that's 1, I'm sorry, of max1, right? So it's fg1, max1, right here, fgf1. Now we work that out, we can see sum of forces of 1, right, is equal to m e1 equals 0, which this means mg sine theta from earlier minus n, right? Because you got to remember there's normal forces also being applied to this box, right? We can't forget that part. So then after we work that out, we'll eventually be left with the equation we need for number 4, which is mg sine theta. And after we get that, right, we would plug this back into this equation. I'll show you right now. Right here. Let me do it right now. Sorry, my screen is glitching. So here, mg sine theta minus g sine theta equal to max1. After we get that, we cancel out the m's, m and m, right? So then we'll be able to, we're trying to isolate, really, the ax1 here, so we could be able to plug it in and replug it into a different equation. So right now we have the ax1 here. Now by itself is g sine theta minus mg sine. I've been saying sine this whole time. I meant to say cosine on some of them, right? Cos theta. I'm sorry. I've been saying sine on some of these that are supposed to be sine of theta. I mean, some of them are supposed to be cosine of theta. So we do that. When we plug it in, right, it'll be plugged into this number here. a1x equals to 10 times 1/2 minus 0.3, 10, 30. That's the 30 here. And then we'll be left with that equation. So a1x equals to 10 times 1/2 minus 0.3 times 10 to cosine 30. And then we have another equation we could input, which is this one, v2 minus v initial squared. So 2ax1, so a here, delta x1. and then we plug it into here again. It breaks down into here. 2a delta x1, which would go into our original problem which was like this, right? And eventually, when we plug those numbers in, our final will be 3m. Now, the way we got to that was by breaking down the equation, this equation here, that final equation I showed you of vx squared minus v initial x squared equals to 2a delta x. The way we got to that was from this equation specifically. 1/2 at squared. So that's how we got from that equation to this one. I'll rewrite it again just so you can understand what I'm saying, just in case you did understand it the first time. Equals to 2a delta x. Okay, so yeah, that's our problem.